Hello friends. So as we have seen that in any manufacturing drawing we are using different symbols for it. For example 32S7, 25S7 or 32N6. So how to understand these symbols? So these are derived from the system of limits and fits. So here the different designations which are used are there. So the first letter which will give the basic size. So here in this example the 60 is the basic size, and this basic size is same for hole and shaft. So basic size is derived from the design calculations, so it will be the single size. Then capital letters are used to designate hole. So here capital H is the designation of hole. Then small letters are used to designate a shaft. So here small f is used to designate a shaft. Then this letter after the capital H is known as a tolerance grade of a hole, whereas the letter after the designation of the shaft is the tolerance grade for the shaft. So according to the Indian standard of system of limits and fits, we are having capital letters are used for the holes and the small letters are used for the shaft. So for example here capital letter A to G, which is above the zero line, are used to designate a hole, whereas H is on the zero line and J to ZC it is below the zero line. Whereas small letter are used to designate a shaft. Small a to small g it is below the zero line, H is on the zero line, and J to ZC it is above the zero line. So there are 2-3 conclusions we can make from this. The first conclusion is that the dimensions of the hole are progressively becoming undersized because this is a zero line for the basic size, and progressively the dimensions becoming undersized. Whereas for shaft, the dimensions for the shaft are progressively becoming oversized. So this is the shaft dimensions and progressively it is increasing. The dimensions for the H hole and H shaft, they are on the zero line. So this diagram can be simplified in this manner. So the capital letter A to G is on the above the zero line, H is on the zero line, and capital letter J to ZC it is below the zero line. There is a small letters which are used for the shaft. So small a to small g it is below the zero line, H is on the zero line, and J to ZC it is above the zero line. So there are 25 different holes and shafts are there, so which are designated as A to ZC. There is a designation letters I, L, O, W are not there, and ZA, ZB, ZC are added to it. So 25 different shafts and 25 different holes are there, and the same system is used for the designation of the system of limits and fits according to Indian standard. So for example, if you take an example of a 45 E8 E7, so 45 E8 E7, so where it will be 45 is the basic size, capital E is the designation of the hole, so it is above the zero line, 8 is the tolerance grade for it, small e is the designation of the shaft which is the below the zero line, and 7 is the tolerance grade for the shaft. So we'll see what is this tolerance unit is and how these tolerance grades are calculated. So as we have seen in the earlier example that we are using the tolerance grade 7, 8. So in all there are 16 to 18 tolerance grades we are generally using. So 18 tolerance grade according to the Indian standard we are using, starting from IT01 to IT0 and IT1 to IT16. So this IT16 grade is used for the manufacturing processes which are having low accuracy like a casting, whereas a IT01 to IT4 are used for the gauges or the plug gauges which are highly accurate manufacturing processes we are using like a lapping or super finishing processes. And all other processes grades are lying between this IT6 to IT14. So for example, how to remember these grades? So IT6 grade you have to remember, that is IT6 equal to 10i, and all other subsequent grades can be calculated based on this. So for example, if you want to calculate IT7, so we have to multiply this 10 by the fifth root of 10, so that will be equal to 16. So if you want to find out IT8, multiply the previous grade, that is 16, by fifth root of 10, so we'll get 25, and so on. We'll get a 40, 64 by multiplying the fifth root of 10. So as I told you earlier that IT01, IT0 are used for the super finishing processes like a lapping, diamond boring, and which are used for the gauges, whereas IT16 is used for the sand casting. But if you are turning, boring type of a general manufacturing process, IT8 grade is used. So the accuracy wise, the as we increase the grade, the accuracy will decrease. So sand casting is having the lowest accuracy, whereas the super finishing process having the highest accuracy. And this fundamental tolerance unit is used to find out this grades, because we are using 16i, 10i. So this I is known as a fundamental tolerance unit. And this fundamental tolerance unit is given by one empirical relation, that is 0.45 cube root of d plus 0.001 d. So this d is the geometric mean diameter. So this geometric mean diameter is calculated as under root d1 into d2, where the d1 and d2 are the two dimension steps. So for example, there are dimension steps which are given as per the Indian standard: 1 to 3, 3 to 6, 6 to 10, 10 to 18, 18 to 30, and so on up to 400 to 500. So for example, if you have a 60 mm diameter, so it lies between this 50 to 80 group. So the geometric mean diameter for it is can be calculated as under root 50 into 80. So we get the value of geometric mean diameter, and which will substitute in this equation of a fundamental tolerance unit, where we'll calculate the value of I. But this value of I is in microns, that we have to remember. Otherwise, we'll get a problem when we do the calculation. And once we calculate the I, then we can use this various tolerance grades, and we can find out the value for the tolerance for the shaft as well as for the hole. And the tolerance grade for the highly finished jobs can be calculated by using these three examples. IT01 is 0.3 plus 0.008 into D, IT0 equal to 0.5 plus 0.012 D, IT1 equal to 0.3, 0.02 D. Then the fundamental deviation, as we have seen the definition for it, the fundamental deviation for various grades of shaft are given here. So no need to remember it. This data will be available in design data book or all engineering metrology book. So we can find it out. But we can remember one thing, that for holes, the fundamental deviations are calculated, and these values are given for the H shaft if you consider, or for H hole if you consider. The fundamental deviation is 0, because the H shaft or H hole is always on the 0 line. So the fundamental tolerance and all these things are given. So with this discussion what we had, we will take one example, that 30S7P6. How we can find out a fitment for this? So 30 is the basic size, which is same for the hole and shaft. Then H is the tolerance grade, or H is the designation of the hole, which is on the 0 line. Now H7, so IT7 is the tolerance grade for it. So IT7 is equal to 69. So we can find out the tolerance value for it by finding out the fundamental tolerance unit. Then the designation of the shaft is P. So we know that A to G is below the 0 line, H is on the 0 line, J to Jersey above the 0 line. So there will be P shaft will be always above the 0 line. And P6 is there, so IT6, which is 10I. So you can find out the tolerance for it. So if you go through this figure, just by going through this figure, we can understand that the hole dimensions are smaller than the shaft dimension. So always there will be an interference fit if you use this grade S7P6. Similarly, if you use S7F6, the shaft dimension is always lesser than the hole dimension. So always there is a clearance fit. So just by these 5 letters, we can find out the sizes for the hole, sizes for the shaft, its fitment, the type of clearance, type of interference, the maximum clearance, maximum interference. All these values we can calculate from this. So you can see over here, we can find out the shaft dimension, we can find out the hole dimension, we can find out tolerance for it, we can find out fundamental deviation for it. So here we are getting a interference fit. There are different types of fits are there, like a shrink fit, then heavy drive fit, press fit, and the tolerance and the designations are also given over here for it. Also for the transition fit, even though it is not used in a practice. Then in the next part of our lecture, we'll see the limit gauges and uses of these limit gauges and how to design these limit gauges based on the Taylor's principle. Thank you.